this is Nimla Rednam. In this video, I am going to start the topic Understanding Quadrilaterals from NCERT textbook class 8. Right? So as you can see here, we have started off with the definition of a plane surface and a plane curve, and then we are moving on to the definition of polygons and the classification. Now what is a polygon? A polygon is a simple closed curve made up of line segments. Now I want you to understand this very clearly, okay? So now here, let me first start with the curve. What do you mean by a curve? A curve is a trace left by a moving point, right? Now if you have a moving point, the trace left behind by this moving point is nothing but a curve, right? Now we are interested in plane curves. What are plane curves? This is a specific class of curves which lie on a given plane, right? Any curve that lies on a plane is called a plane curve, right? Now here, these plane curves are further classified into open and closed. As the name suggests, you can see that an open curve is a curve whose starting point and end point are not the same, whereas a closed curve has the same starting and end point, right? Or you can say there is no end point, right? Now these closed curves are further classified into non-simple and simple. What do I mean by simple and non-simple? Now here, if this closed curve happens to cross itself once or more times, then it is called a non-simple. As you can see here, it's crossing itself at this point, this and this point, right? Then this is a non-simple closed curve. Whereas a simple closed curve will not cross itself, right? It is not going to cross itself. Now here, simple closed curves are further classified into concave and convex, right? Now what is the meaning of concave? If I have a simple closed curve and I join any 2 points, okay, if a part of it or the entire line segment or a part of the line segment lies outside the simple closed curve, then it is called a concave curve, right? And if it always lies entirely inside, then it is called convex, okay? Now this is a convex because if I join any 2 points, it is always going to lie inside, right? If it happens to lie outside, the line segment happens to lie outside in one or more instances, then it is called concave, otherwise it's called convex, right? Now here, where does the polygon come in? Now here, polygon is a simple closed curve, only thing is it is made up of line segments, right? If it is made up of line segments, we call it a polygon, okay? Now here in polygon, like for any simple closed curve, we have the classification convex and concave, right? I have the classification concave and convex polygon, right? And now this is about concave and convex. Now after this, we will be looking at regular polygon and irregular polygon. Now what is that? Now here, if I have all angles equal, right? If I have all angles equal, let us start here. If in a given polygon all angles are equal, that is, it is equiangular, and all sides are equal, that is it is equilateral. Equilateral means all sides are equal. If these two happen, then we call it a regular polygon, okay? Otherwise it is called an irregular polygon, okay? Now this is a regular polygon when you have equiangular and equilateral, and if it is not equiangular and equilateral, it is an irregular polygon. Now here I have a question for you. Can a regular polygon be concave? I want you to think about it. Can a regular polygon be a concave polygon? Okay, right. Let's go back to our textbook. So as you can see here, they have given examples of polygons and examples of curves which are not polygons. You can clearly see that here this curve is crossing itself, therefore it is not a polygon. Here again it is crossing itself at 2 points, therefore it is not a polygon. Here this is not closed in the first place, therefore it is not a polygon. You can see that the starting point and the end point are different, right? And then they have given few examples of convex. You can see, you can join any 2 points here, you will see that it always lies inside the polygon, therefore it is convex. Here you will see that there are many instances where a part of it or the entire line segment lies outside the closed curve, therefore it is concave, right? So that's convex and concave. Now coming to regular and irregular, as we have discussed, regular means it is equiangular and equilateral. They have given a few examples here. So as you can see, this all three angles are equal, three sides are equal, right? So this is a regular triangle or an equilateral triangle as we call it. Here all four angles are equal, all four sides are equal, therefore it is a regular quadrilateral, or as you know, it is a square. Similarly, regular pentagon and regular hexagon, right? Next, these are a few examples of non-regular or irregular polygons. You can see that all angles are not equal in this case, all sides are not equal in this case, and in this case again all angles or sides are not equal, and so on, right? So with that we finish the discussion for 3.1. Let us start the exercise. Now here they are saying, they have given a few figures here and they want us to classify each of them on the basis of whether it is a simple curve, simple closed curve, polygon, convex polygon, or a concave polygon, right? So for this what we are going to do is, let us draw a table. Here I have already drawn a table and I have to fill in the details here. They have given A is simple curve, so let me write A here, simple curve, right? Okay, and then B is simple closed curve, simple closed curve, right? And then I have polygon, and then I have convex polygon, and the next is concave polygon. Okay, now I have to classify the given curves based on these. So I have 8 figures given to me. I'm going to write these 8, 5, 6, 7 and 8, right? Okay, so let me draw the first figure here for you. So this is how it looks like. This is my first figure, right? So is this a simple curve? What do we mean by a simple curve? It does not cross itself, right? That is a simple curve. As you can see here, we have already defined a simple curve does not cross itself. It is closed and it does not cross itself, right? So here you will see that this is definitely a simple curve, okay? And is it a simple closed curve? Yes, it is a simple closed curve. Now they are asking, is it a polygon? What is a polygon? A simple closed curve made up of line segments. Now clearly this is made up of line segments, therefore I can say that this is a polygon. Now I have to check whether it is a convex polygon or a concave polygon. Now is it a convex polygon? It is not, because you can see that there are a few, if I join points, some of them the line segments lies outside the curve. Therefore it is a concave polygon, right? So this is your first figure. Next, coming to, this is a kite as you know it, right? Is it a simple curve? What do you mean by a simple curve? Again, simple curve is a closed curve which does not cross itself. So this does fit the description and it is a simple curve. Is it closed? Yes, it is closed. Is it a polygon? That is it made up of line segments? Yes, it is made up of line segments. Is it convex? Yes, it is. It's not concave, it is convex, right? So that is your second figure. Next, coming to the third figure, this is the figure given to us, right? Now here, is it a simple curve? It is not a simple curve in the first place, because you can clearly see that this is not one single curve at all, right? So it does not fit the description for simple curve or simple closed curve or a polygon or convex or concave for that matter, okay? So next is, they have given a star, right? So now here, is this a simple curve? Simple means it does not cross itself. Here clearly it is crossing itself a number of times, so it is not simple. Okay, if it is not simple, we cannot talk about it being a polygon in the first place. Okay, so it does not fit the description of simple or a polygon or convex or concave. Okay, next, coming to the fifth figure. Now, does it cross itself anywhere? No, it does not. It is closed, right? So it is simple, it is closed. Is it a polygon? Is it made up of line segments? It is not made up of line segments. So we can't talk about it being convex or concave. Okay, so that is about our fifth one. And then I have this figure. Is it simple? It's not crossing itself anywhere and it is closed. Okay, is it a polygon? It's not a polygon. That's not a polygon, right? Next, I have something like this. Okay, now here, okay, is it a simple curve? Yes, it is a simple curve, right? Because it's not crossing itself anywhere and it is closed, no problem. It is not a polygon because I don't have all line segments. Okay, I have only two line segments and then it is a curved part, remaining part is curved. Next, coming to the eighth figure, I'm going to draw it here. Okay, is this simple? It is not simple because clearly you can see that it is crossing itself at this point and at this point. So it is not simple, it is not closed, it is not a polygon. Okay, so this is about the first sum in our exercise. Okay, next, coming to the next one, they're asking us what is a regular polygon. Okay, now we have already seen the definition of a regular polygon. A regular polygon is a polygon which is both equiangular and equilateral, right? This is your regular polygon. And then they're saying state the name of a regular polygon of three sides. We already know that a regular polygon of three sides is equilateral triangle, right? We call it an equilateral triangle. Equilateral triangle. What is a regular polygon of four sides? You know that it is a square, because all angles are 90 and all sides are equal for a square. Of six sides, it is called a regular hexagon. Okay, it is called a regular hexagon, right? So that is about our first exercise. Okay, so now, in the next video we will be looking at some of the measures of the exterior angles of a polygon and we will complete the second exercise, right? So here I want to discuss further about this phrase simple closed curve that we came across. Very often in mathematics, what happens is we use terms which are so simple, and it's more like we are trivializing what is being said. Okay, but it has a very deep meaning. So recently I started reading this book, Mathematics and the Imagination. I finished the first chapter, and it so happens that he's talking about simple closed curves here. So I would like to just read out a few lines here. I thought you'll find it interesting. So here he's talking about how, can you see? Yes. How maths is the science which uses easy words for hard ideas. Okay. Now I can't explain the whole chapter of this book now, but I would like to mention a few points here. Right. So for example, they use easy words for hard ideas. What do we mean by this? For example, we have words like fields, groups, okay, families, spaces. These are all everyday use English words, right? But the meaning when it comes to mathematics is, it has a very deep meaning, okay? So for example, another word is like, for instance, the word function probably expresses the most important idea in the whole history of mathematics. Yet, most people hearing it would think of a function as meaning an evening social affair, while others less socially minded would think of their livers. The word function has at least a dozen meanings, but few people suspect the mathematical one. The mathematical meaning is expressed most simply by a table. You will look at the relation between two variables and see how one depends on the other, right? That is the simplest way of expressing function in mathematics, right? So that is one word that we are talking about. And then if you look at the words in calculus, integration, differentiation, okay, all these words have very deep meaning. And then we come to our simple curve. I just want to read it out once. As we see, mathematics uses simple words for complicated ideas, okay? We've been discussing that in this entire chapter in this book. An example of a simple word, okay, used in a complicated way is the word simple itself, okay? Now, the simple curve and simple group represent important ideas in higher mathematics. As you can see here, this curve here, okay, the above is not a simple curve, okay? A simple curve is a closed curve which does not cross itself and may look something like this. Now, this figure over here is a simple curve, as you can see, right? This is a simple curve, whereas this is not a simple curve. This is just to make you understand that although the phrase seems very obvious and very familiar, you need to understand, have a very good clarity of what that word or phrase means when it comes to mathematics, okay? So there are many important theorems about such figures that make the word worthwhile. So understanding a simple curve is very important, is what he's trying to say, right? So I just wanted to, re-emphasize and try to explain the fact that just using the word simple curve, you cannot just use it as you like it. You need to understand the criteria, the criteria which makes the curve simple. It is not like the curve looks simple, therefore it is a simple curve, right? Yeah. So with that, I would like to end this video, and in the next video, as I said, we will be looking at the exterior angles, some of the measures of the exterior angles, okay?